Wasseim, and myself, Wasseim. Our advisor is Dr. Mohammed mentioned, Dr. Mohammed and Dr. Khaled.
What motivated us to do this project is that the deaf people in this region, they lack the attention. So this project aims at improving the quality of life for the deaf community. It facilitates their access to careers and other facilities in society. It's an advance in the state-of-the-art in human-computer interaction, HCI, and to develop the outcome of this project into a commercial, there's a problem. And our problem is a pattern recognition and signal processing problem. And the ideal solution for such a problem follows the following steps: data collection, data labeling, image processing, feature extraction, and classifier training and revision. Our contribution is to all of the above mentioned steps.
When it came to our project, we had to go into a sampling collection phase. In literature, the Arabic Sign Language consists of 1,400 plus gestures. Out of these, we decided to implement a subset of 23 gestures. The samples were collected both inside AUS and outside AUS in order to determine the boundaries of the gesture and the states inside the gesture. Here's a sample of the gesture. Sadiq. Because all we have is a sequence of data that are time dependent. Hidden Markov models are proven to be robust in
this digital video camera. The system captures the live video stream from the digital video camera by MATLAB. The video stream is further, the video is segmented into images, and the images are extracted at the rate of 5 frames per second. In training, since training is done offline, images are segmented manually, while in recognition, images are segmented using MATLAB and real time. We've got the filtering and noise reduction. We filter the images that are supplied, filtering such as background, we filter out the background, the colors of the clothing, the lighting effects, and some noises associated with the images, such as Wasseim said. Then we feed these images into the word silence removal phase, silence recognition phase, done in recognition. Then we feed the images into feature extraction and calculation phase. In feature extraction, we use the discrete cosine transform DCT, which is based on the fast Fourier transform model. This into the upper left corner of the image. The important features are compacted there, and the unimportant, or let me say it, irrelevant features are scattered around. To make use of this compact, but HMM later outperformed the neural network for modern knowledge. As you can see in the table below, table shown, we first did the test using 15 test cases coming from the same data source. HMM gave us the result of 98.4%. Neural networks gave us almost 100% success rate. Later on, we increased the test cases, and the test cases were coming from 3 different sources, i.e. 3 different signing persons. HMM gave us a 96% success rate, and neural networks dropped to 90%. Accomplishments. As far as we know, this is the first Arabic Sign Language translation system developed. We have won the first place, our project won the first place in the second AUS Mechatronics International Symposium, and our project won the first place in the NAC competition from the CA department. And we are in the process of writing a paper to be submitted to a international journal.
As for every project, we have obstacles. In our project, the obstacles were first, there is a lack of research in this area, in this region. So we had to do lots of research on our side. Unlike other sign languages, we don't have an available Arabic Sign Language database so that we can use, which meant that we had to do the data collection on our own, which is not an easy process because we had to get people who are fluent in this sign language, and we had to ask them to do the repetitions enough time so that we can train our system. Furthermore, furthermore, the region lacks ARSL experts. So over here, we could only get use of the Sharjah humanitarian system, Mr. Salah Hawda, as an expert for our system. Furthermore, as in any artificial intelligence system, our system needs more and more data. There is never enough data for our system. We're also dealing with live video streams, which means that we need tremendous processing power and many delays. And finally, other courses at AOS.